Alrighty, so today we're going to be doing some past paper questions on sound. It's a physics topic, really easy, and I'm going to try and cover as many questions as possible. Okay, so let's get started. Okay, a device at the bottom of the sea emits a sound wave of frequency 200 Hz. The speed of sound in seawater is 1,500 meters per second. Calculate the wavelength of the sound in seawater. Now, I told you that while solving these past papers, I'm gonna try and cover as much of the topic. So I'm going to now dissect the topic of sound, and so as much of the topic. Okay. So first of all, a device at the bottom of sea emits a sound wave of frequency 200. Okay, so first let's take these two keywords, sound wave and frequency, from this. Sound waves are basically they're waves, or sound waves are, I'll write that here. Sound waves are, they're vibrations. They are vibrations, that travel through a substance, and they are emitted by a vibrating object, and they are emitted by a vibrating object. Okay, so that's the definition of what a sound, or what sound is. Sound is. Sound waves are basically just the representation of, compressions and rarefactions in a much easier way. Now, since I said compressions and rarefactions, I'll just explain that. So let's say we have a vibrating object, and let's say it's a speaker. Okay, this is the speaker. Okay, so, and I forgot to mention one thing, that waves, or any type of wave, sound waves, light waves, electromagnetic waves, okay, they don't carry matter, or they don't move matter. Okay, they do carry energy. So they carry energy, but not matter. So just to explain how, I'll do this example with the speaker. So let's change color. So this is the speaker, and as you guys know, a speaker is a vibrating object, or at least this part of the speaker. So when it vibrates, okay, it causes the surrounding particles, air particles, to vibrate as well. So let's say that there were just a bunch of particles, air particles, which were surrounding this, and the vibrations produced by the speaker caused them to carry energy, but they didn't move from their place. I'll just show you how. Okay, so let's say these are a bunch of air molecules, okay, and the vibrations cause them to now they have energy. And let's say that there were a bunch of other air molecules over here. Okay, so there are a bunch of another bunch of air molecules here. What will happen? The vibrations the vibration of the speaker will cause these particles, or molecules of air, or the air particles, to move. These air particles will then, they'll gain a bit of kinetic energy, and they're going to bump into these particles over here. And when they do, they're going to go back into place. Okay, so let's just give another. So here's one air particle, here's another, and here's the speaker. Okay, the speaker vibrates. It causes this particle to move and carry energy. this bumps into this particle, then this particle bumps into another particle, while or let's just call this A, B, C. Okay, so A bumps with B, causing B to gain the kinetic energy, and A moves back into place. B gains the kinetic energy and then bumps with this over here, this or C, and then loses its kinetic energy while C gains. So that's how sound works. Okay, now one of the things is that, or sound has compressions and rarefactions. Compressions are a region of sound waves in which the concentration, or where particles or molecules are tightly packed together or are close together. Rarefactions are a region in which or where the particles are far apart from each other. Okay, so now let's talk about frequency. Let me just change color. Let's do pink. So frequency is a calculation of 1 over t. T is time, and it is the number of seconds it takes for one vibration. And frequency itself is the number of vibrations per second. Number of vibrations per second. That's okay. So now we know that. I'll just solve this question. We've gotten a bit too deep. So the speed of sound in seawater is 1,500 meters square. 1,500 meters per second. Calculate the wavelength of sound in seawater. Just one more thing. Last thing I'll mention, which is off this, is that sound travels fastest in solids and slowest in gases. That doesn't mean like in gases they immediately stop. They have some kinetic energy. Okay, so remember, they carry energy, which is sometimes kinetic energy. In this form it's kinetic energy. However, they do not carry matter. Very important point. Okay, so now let's just solve the question. Okay, so calculate the wavelength of sound in seawater. Okay, so you guys need to know a formula. Is that we can calculate the speed of sound. Let's say speed of sound by knowing the frequency and wavelength is equal to frequency multiplied by wavelength. Okay, wavelength. Okay, and I'll just tell you what wavelength is. If we have a wave over here, okay, wavelength is basically the distance between two similar points. Okay, so this is wavelength. This can also be the wavelength. You know, they're the at same positions in the wave. So yeah, in one wave. Okay, so we have speed, which is 1,500 meters per second, and we have frequency, but we don't have wavelength. That's what we need to find. So we have 200, and let's just call wavelength x. Okay, so x and 200x, 200x would be equal to 1500. So x would be equal to, let's just do this. So this gets cancelled out, this gets cancelled out, and therefore it's going to be equal to 7.5 meters. Okay, you can have your scientific or a normal calculator to check that, because sometimes in exams people, you know, they do these kind of calculations without doing them properly, and they mess up. So yeah, having a calculator would help this meters. Okay.